The 5 was the law of sines. And just a real quick recap on the law of sines is where you have the sine of A over side A, sine of B over side B, sine of C over side C, and those are all relational, all proportional to one another. And we use the law of sines when we have sides together, or a couple sides and an angle, but the angle that's given has to have a side that is corresponding to it. So like if angle C is given, then I have to have side C given in order for it to be used for law of sines. So what if that angle and that corresponding side are not given? What do I've got an issue, because the law of sines is used when I'm trying to find the side lengths or angles of a triangle that is not a right triangle, does not have a 90 degree in it. So that's where the law of sines, that's where the law of cosines come into play. Now we have to have the law of cosines, because what if side lengths and angles are given, but they don't correspond to each other? So I've got like side A, side B, angle C, but no side C. Well, now I've got a problem. And so there is where we have our law of cosines. Law of cosines can be used in any situation. Law of sines is kind of a shortcut for us. But the law of cosines can be used in any situation that we have. And so right now, before we get started, I would like you to label these as 1, 2, 3, just so I have an easier time in recognizing which equation we're going to be using. So here we go. So we have a triangle ABC, and side A is 10, side B is 4, and angle C is 25 degrees. Okay, before we get started, always double check to make sure, since that's written as degree, that your calculator is in degree mode. I had somebody saying, I'm not getting it. Well, check your mode. Well, they were in radian mode, not degree mode, so double check that. So what we need is we need side C, we need angle A, and we need angle B. Side C, angle A, and angle B are what we're needing. And since I need side C and angle C is given, I'm going to go to the equation that has the angle C in the formula. So that would be equation number 3. So that's why I'm choosing number 3, is because I have angle C given. So I'm strictly going to then be plugging in for A, for B, and for angle C. So C squared, of which I do not know, stands alone. A squared, so that's 10 squared, plus 4 squared, minus 2 times A times B times cosine of angle C, which is 25 degrees. Now, when I am looking for my side that I'm solving for, you can take everything on the right-hand side of that equal sign as long as there is no variable written there. You can plug that strictly into your calculator as 10 squared plus 4 squared minus 2 times 10 times 4 times cosine of 25. I highly encourage that you pick up your calculator and you do that. Do not wait to see if that works on the test, because we have many different mistakes that we can make, maybe not necessarily on this one, but on the ones coming up. Mrs. Meyer, do we have to write all of that out? The answer to that is yes, as long as if you want credit. Because if you miss the answer and you have no work, the entire thing is wrong. Whereas if I can see that you have this correctly used, and so then it must have been something that you've done with your calculator, this is like half the points right there.
But on the final, we don't get half credit, right?
You do not, because you have it as multiple choice. So you should have gotten C squared equals 43.5. That is rounded. Taking the square root of that, you should have 6.6. And the more accurate would be not to round, and then just take the answer that you got for all of this, put that under the copy and paste that under the radical, but rounding it, you still would get 6.6. okay? So that is my C as 6.6. Now I look at my list of items that I need. I still need angle A and I still need angle B. At this point, it doesn't matter which we use first. I'll probably just go with B because that comes next. And so that leads me to equation, I'm sorry, A. I don't even know my alphabet. Angle A, and so that leads me to equation A, or number 1, okay? So I'm going to plug in exactly everything that is written on equation number 1. So A squared is 10 squared equals B squared, 4 squared, plus my new C squared, which is 6.6, minus 2 times 4 times 6.6, which is B times C, times the cosine of A, of which I do not know. Now this is, in this situation, this is where our mistakes are going to come. On equation 3, again, unless you're not in degree mode, if you type that in exactly as it is, you're going to get the correct answer. But over here on number 1, or excuse me, over here on this section when I'm looking for an angle, this is where the mistakes will come because of your algebra work. I've seen it over and over and over again. So please, please, please heed my advice here. You're going to have to, you can't just type this straight into your calculator. You're going to have to work it in pieces, okay? So the first, 10 squared, is 100. Then you're going to, this negative sign, you can look at that as two pieces, things to the left of the negative and things to the right of the negative, because the things to the right of the negative become a coefficient to that cosine. So you're going to take 4 squared plus 6.6 squared by itself, and you're going to figure this out. It's going to look like this in your minds. So 4 squared plus 6.6 squared, I think comes out to be about 59.56. And then in your calculator, you're going to take 2 times 4 times 6.6. And you should get 52.8. You are not taking C squared minus 2 times B times C. This is all being multiplied together, therefore this cannot be separated. Now I subtract 59.56 from both sides. And 100 minus 59.56 is 40.44. And again, my negative 52.8 is being multiplied. It is the coefficient to my cosine A. That's being multiplied, so therefore I divide by negative 52.8. And I have 40.44 now divided by negative 52.8. And that's going to be my cosine A. But with that, I still don't have my angle. That's the cosine of A. To find the angle measurement, I take the inverse, and that's what's going to give me my A. So inverse cosine on your calculator, A ends up to be 140 degrees. How do I find angle B from that without having to go through all of that all over again?
180 minus 25 minus 144.
Perfect. And angle B ends up to be 15 degrees. So that's where two sides are given in an angle, but the angle is not corresponding to any of the sides that are given. So that's a huge hint. I need to use the law of cosines. So for instance, if I had A equals 10, C equals 4, and angle C is 25, easily use law of sines. because my angle C and my side C correspond to each other, and so therefore I wouldn't have to go through all of the law of cosines, and I could just go strictly with law of sines. But because side C is not given, angle C was, I need to revert back to the law of cosines. Yes, yes. I'll probably give that to you tomorrow. I mean, I have it.
Use law of sines right after the fullest law of cosines.
You are the first person that asked that. So use it where?
Right after you find
C. C? All right. I want you to pay close attention to what do I have here? Side, side, angle. So I have that situation to where I would have my varying triangles. And because of that, with law of sines, you need to stick with law of cosines. Because if you use law of sines on this, you would have to do an extra step in order to come up with this. When do I do the 180 minus, whatever? But by using law of sines, you have a tendency in which to get the other angle that is not appropriate to what we have, finding the other triangle. So my suggestion is stick with law of cosines through. I was wondering if somebody would ask that question. You're the first one to ask.
Because I did it and I got the same answer.
You did? What angle were you looking for?
I got A of 140.16 and I got 14.84.
Using all the C information? Huh. Because I had tried to do that up as an example, and it came out to be where I had to take 180 minus that. I'll look at yours. I'll look at yours. That's awesome. Okay, second example. Solve triangle ABC, but now notice I have three sides, 9, 7, and 5. What's missing? And all my angles. So I need angle A, I need angle B, and I need angle C. Angle A, angle B, angle C. But that is the reason why to shy away from the law of sines, just because you have a tendency to get that other second triangle that sometimes doesn't work, even though it might have worked for that. No, for yours it was a legitimate way in which to do it, but that's not always the case, I guess is the way I would say that, okay? All right, so I'm looking for these three angles. Formula 1, 2, 3, doesn't matter which. I'm going to start with number 1. I want you guys to be rebels. I'd like you guys to start with a different formula. Not mandatory, because I'm not going to check your notes, but I just want you to see that it doesn't matter, and it'll be a little bit more practice on your part if you kind of do a standalone on that. But again, we're just plugging in, and it's going to be worked similar to this second part of the first example that we did here. So I'm going to use number 1 because I'm going to find angle A first. So I'm going to do A squared, B squared plus C squared minus 2 times B times C times the cosine of angle A. And just remember that everything to the left of the negative can be worked together, but everything to the right needs to stay connected. So 9 squared is 81. And mine, 7 squared plus 5 squared, I can do, is 74. And then 2 times 7 is 14. 14 times 5, 70 times cosine of A. So I subtract first. So 7 equals negative 70 times cosine A, and then I divide by the coefficient of the cosine. And any time that you want an angle measurement, you use inverse. On the calculator. Inverse cosine of -1. Double check that. And you guys probably know that if you're using the negative, you need to use the negative button at the bottom of your calculator. So A is 96. And this stands alone, meaning when I find either B or C, or depending upon which one you started with, I'm going to start from scratch. Because finding angle A has no reflection on finding any of the other angles. So now I'm going to go to angle B, which is equation number 2. 7 squared, 9 squared, plus 5 squared. Times the cosine of B. And everything to the left of the negative, I can add together. So 81 plus 25 for my example. And then I multiply 2 times 9, 18 times 5. It's 90 times the cosine of B. I subtract before I divide. I get -57 equals -90 times the cosine of B. Now I get to divide. Looking for an angle, I use the inverse. Double check my work. And you would get 51 degrees for B. And anytime I have two angles and I need to find the third, I can take 180 minus A minus B, and that will give me C, which is 33 degrees.